In this video, we are going to see about the fast Fourier transform. The fast Fourier transform is a method for computing the discrete Fourier transform with reduced number of calculations. The computation efficiency is achieved if we adopt a divide and conquer approach. This approach is based on the decomposition of n-point DFT into successively smaller DFTs. This basic approach leads to a family of an efficient computation algorithms known as collectively as FFT algorithms. Radix are FFT. In an n-point sequence, maybe 4 or 8, in fast Fourier transform, n is represented as r power m. Okay, the sequence can be decimated into r point sequence. For each r point sequence, r point DFT can be computed. From the results of r point DFT, r power 2 point DFTs are computed. From the results of r power 2 point DFT, r power 3 DFTs are computed, and it process still get over till it reaches r power m point DFT. This FFT algorithm is called as radix RFFT. Let's take an example. If n is equal to 8, r is equal to let r be 2 and m will be 3. So I am going to perform radix 2 operation up to 3 stages. Okay, so m is the number of stages. So this is the example of computing 8-point DFT via radix 2 DAT FFT algorithm. As we all know, FFT consists of two types of algorithm: decimation in time and decimation in frequency. So we'll see about the decimation in time. So here first we'll be going for bit reversal. The input sequence will be in the order of 0 to 7. So that will be bit reversed in this order, and we will be pairing first two values and we'll be computing 2-point DFT, and remaining values like 3 and 4, 5 and 6 and 7 and 8 are computed using 2-point DFT. The results of this first stage is given to the next stage 4-point DFT. So the first 4 values are given to the next 4-point DFT, and the remaining 4 values are given to the next stage 4-point DFT. The results are computed, and finally we are getting 8 values, and the entire 8 values is given to the 8-point DFT stage. Okay, so finally we are getting the answer. So this is the procedure of radix to DAT FFT. So we'll see now the flow graph or butterfly diagram for first stage computation for performing 2-point DFT. So first, initially we will be proceeding with the bit reverse order. So as I said, these two lines are paired. We have a total factor W2 power 0 for entire structure. So the first two inputs are added in this format, like A plus B into total factor, and the second line is subtracted, A minus B into total factor. The same format is proceeded in next two lines for x of 2, x of 6, x of 1, x of 5, x of 3, x of 7. So the final answers of 2-point stage is taken here as an input, and it is given to the 4-point DFT for a calculation. So here we have first 4 points as a separate the value, and our next 4 points is taken as a separate lines. So here in the first 4 lines, we are taking first line and third line as a pairing option, and second line and fourth line as a pairing option. So we'll be adding the first line and third line, and we'll be writing here, and we'll be subtracting the first line and third line in the subtracted answer will be written in the third line output. The same procedure is followed in second line and fourth line. So here the operation is like this. So f1 of 0 is equal to v1 of 1 of 0 plus v12 of 0 w4 power 0. So in the third line we have a total factor w4 power 0. In the fourth line we have w4 power 1, which is equal to minus j. So the subtract answer will be like this. f1 of 2 is equal to v12 of 0 minus, it will be 1 only. It will be 1 of 0 v12 of 0 w4 power 0. Next f1 of 1, so we'll be pairing second line and fourth line v11 of 1 plus v12 of 1 into w4 power 1. f1 of 3 will be v11 of 1 minus v12 of 1 w4 power 1. The same procedure will be proceeded here for the next 4 lines. Now here the final answers of 4-point stage is given as an input to the 8-point stage. Here we will be pairing first line and the fifth line, second line and sixth line, third line and seventh line, and fourth line and the eighth line. So these are the pairings we are done. So the first line and fourth line, so let it be x of 0 is equal to f1 of 0 plus w8 power 2 f2 of 0. So this is the straight away we are given. Similarly, in fifth line, f1 of 0 minus w8 power 0 f2 of 0 is equal to x of 4. Similarly, in second line and sixth line, f1 of 1 plus w8 power 1 f2 of 1 is equal to x of 1. f1 of 1 minus w8 power 1 f2 of 1 equal to x of 5. f1 of 2 plus w8 power 2 f2 of 2 equal to x of 2. f1 of 2 minus w8 power 2 f2 of 2 equal to x of 6. Finally, f1 of 3 plus w8 power 3 f2 of 3 is equal to x of 3. f1 of 3 minus w8 power 3 f2 of 3 is equal to x of 7. So finally, we'll be getting this answer. So w8 power 0, w4 power 0, and w2 power 0 always will be 1. w4 power 1 is minus j. w8 power 1 is 1 by root 2 minus j 1 by root 2. That is 0.7071 minus j 0.7071. w8 power 3 is minus 0.7071 minus j 0.7071, and w8 power 2 is minus j. So this is the combined flow graph of or butterfly diagram of all 3 stages for computation. So finally we'll be writing the answer, and also we'll be drawing the butterfly diagram in this format. So coming to the decimation in frequency algorithm, initially we will be not doing any bit reversal order, but we'll start with 8-point DFT. Okay, so in DIF, the answers are done in the first four lines, added in the first added answers are done in the first four lines, and the subtract answer will be in this next four lines. For example, we have paired 0 and 4, so that added answer is added in the first line, 1 and 5 in the second line, 2 and 6 in the third line, and 3 and 7 in the fourth line. And the subtracted answer will be in this format: x of 0 minus x of 4 into total factor w 8 power 0. So the subtracted value of the paired line is multiplied with the total factor. Similarly, x of 1 minus x of 5 into total factor. So same way it is given in x of 2 minus x of 6 equal to w8 power 2 g2 of 2, x of 3 minus x of 7 w8 power 3 equal to g2 of 3. So these are the output of the first stages. So the output of the first stage is given to the input of the next stage, 4-point DFT stage. The same procedure is followed. First line and third line is paired, and second and fourth line is paired in the first four lines. And first line and third line is paired, and second and fourth line is paired in the next last four line. So same way, first and third line is added first, and second and fourth line is added in the second line, and the values are subtracted of first and third line with g1 of 0 minus g1 of 2 into w4 power 0, and second line and fourth line is subtracted, inputs are subtracted with the total factor w4 power 1. The same procedure is proceeded in the next four lines also. So we have the output of second stage produced, and that will be the input of the final stage, 2-point DFT. So in 2-point DFT, we don't have any separate operation. Just we are going to add the result right in the first line and subtract the result we will be having in the second line. So we have total factor w2 power 0 in all the paired lines. Finally, we will be getting some answer, and that answer should be bit reversed. So this will be in the order, because initially we don't have any bit, we have not done the bit reverse. Finally we have this answer, and that should be ordered in the from x of 0 to x of 7. This is the complete structure of the decimation in frequency algorithm.